We said that solving a log equation is usually a matter of rewriting it as an exponential equation, using the fact that the log base a of x is equal to k if and only if a to the k is equal to x. So like in order to solve the log base 5 of 2x equals 3 halves, we can rewrite that as an exponential equation. 5 to the 3 halves is equal to 2x. And then to get the x by itself, we need to divide both sides by 2. And then we can plug what we have here on the left into our calculator to get that x is approximately 5.59. But now, in order to use this definition of logarithm, we first need to make sure that we have just a single logarithm on one side of the equal sign. And notice in example 2, we've actually got 2 logs separated by an addition. So this is where another one of our properties is going to come in. We learned that an addition of logs can be turned into a multiplication inside of a single logarithm. So this is the same as the log of 20x times x is equal to 5, or the log of 20x squared is equal to 5. And now that we have just that single logarithm on the left, here's where we can rewrite it as an exponential equation. Remember, this is understood to be base 10, so this would be the same as 10 to the 5th is equal to 20x squared. And then dividing both sides by 20, 10 to the 5th divided by 20 is 5,000. So what we have at this point is that x squared is equal to 5,000, which means to solve for x, we can take the square root of both sides, and the square root of 5,000 is approximately 70.71. Now remember, technically, when we solve an equation by taking the square root of both sides, we always want to stick the plus or minus in there. But the reason why we only want the positive 70 in this case and not the negative 70 is because of our domain of logarithm. If you go back to when we were talking about what the graph of a logarithm looked like, we said that it stays on the right side of the y-axis, which means the domain of a logarithm is only positive numbers. Or in other words, we cannot plug a negative number into a logarithm. So if we were to give negative 70 as an answer, when we go back up here and plug it in, we would have 20 times negative 70 here inside of a logarithm, and negative 70 inside of a logarithm here, which we can't do, which is why we don't want the negative 70 as an answer. So just keep an eye out for that as you're solving these log equations. It's possible that you will end up with answers that when you go back and plug them in, they will give you a negative number inside of a log, which means you need to throw them out. They won't actually work. For number 3, similar to number 2, we first want to get a single logarithm on the left-hand side. Now this one is a subtraction, which means we can turn it into a division. This would be the same as the log base 3 of x plus 1 divided by x minus 5 is equal to 2. And then rewriting this as an exponential equation, we would have 3 squared is equal to x plus 1 over x minus 5, which 3 squared is 9. And at this point, we're actually looking at a rational equation to solve. So we need to get rid of this denominator by multiplying both sides by that denominator. So on the left side, we need to distribute the 9 to get 9x minus 45. And on the right side, those x minus 5s will cancel, leaving us with just the x plus 1. And now we're looking at just a basic linear equation to solve. We want to subtract x from both sides, and then add 45 to both sides. So we're looking at 8x equals 46. And then dividing both sides by 8, we end up with 46 over 8, but we can divide both of those by 2 to get a reduced answer of 23/4. In example 4, notice that we have a natural log on both sides of the equal sign. So this is similar to when we were solving exponential equations, and we said whenever we have the same base on both sides, we can just set the two exponents equal to each other. It's the same thing here. When we have a logarithm of the same base on both sides, we can just take whatever's inside those logarithms and set them equal to each other. So in this case, it would be 5x plus 8 equals 40 minus 3x. And now we just need to get x's on the same side, numbers on the same side. So I'm going to add 3x to both sides and subtract 8 from both sides, so that we're looking at 8x equals 32. And then dividing both sides by 8 gives us x equals 4. In example 5, we see a log base 2 on both sides of the equal sign. But the problem at this point is that we have 2 logs on the left side. So we first want to combine them into 1. Since we have an addition sign there, that tells us we can turn it into a multiplication. This is the same as the log base 2 of x plus 3 times x plus 4. And that's equal to the log base 2 of 3x plus 8. And now that we have just a single log base 2 on the left and a single log base 2 on the right, we can take what's inside those two logarithms and set them equal to each other. So now at this point, we need to FOIL on the left-hand side. So that's going to give us x squared plus 3x plus 4x would give us a 7x in the middle, and then 3 times 4 plus 12. And that's equal to 3x plus 8. Which means we're actually solving a quadratic equation for this one. So we want to get it set equal to 0. We want to subtract the 3x from both sides and subtract the 8 from both sides to get x squared plus 4x plus 4 equals 0. And then this factors nicely as x plus 2 times another x plus 2, or x plus 2 squared. And then at this point we want to set each factor equal to 0 and solve. But since they're the same factor in this case, I only need to use one of them. Just x plus 2 equals 0, which means that x is equal to -2. Now remember, we set up here with example 2 that we don't want a -70 as our answer. But that was because whenever we went back and plugged in a -70, we had a negative number inside of a logarithm. For example 5, if we go back and plug in a -2, -2 plus 3 is a +1. -2 plus 4 is a +2. And 3 times -2 is -6, plus 8 is a +2. So even though we end up with a negative value for x, when we go back and plug it in, what we're taking the logarithm of actually turns out to be positive numbers, which makes it okay. So it's not that you necessarily throw out all negative answers that you get. It's when you go back and plug it in, if it gives you a negative number inside of a log, that you need to be concerned about it. But sometimes you will get a negative answer and it will work, as it does in this case. Example 6, we see a natural log on both sides of the equal sign, but again we need to condense this one into a single expression first. So a subtraction we're going to turn into a division. So this is the same as the natural log of 2x plus 2 divided by x equals the natural log of 4. And now since they're both natural logs, we can take what's inside of them and set them equal to each other. So 2x plus 2 divided by x is equal to 4. And just like we did with example 3, we need to get rid of this denominator by multiplying both sides by x. So the x's on the left will cancel, leaving us with 2x plus 2. And then on the right we have 4 times x, or 4x. And now we just need to subtract a 2x from both sides, leaving us with 2 equals 2x. And then dividing both sides by 2, we end up with x is equal to 1.